All right. It is 6:46. Gotta bang out a quick thing so I don't fall out of the habit. Hopefully I can keep it simple. Um, I didn't want to spend the time connecting my microphone. Oh, I'm already in. I didn't want to spend the time connecting my microphone, so using my laptop microphone. Hopefully the keyboard sounds aren't too annoying. Um, and yeah, what did I do today? Let's see. So I think today I worked on my class assignment, which I think is actually pretty cool. So if I go to my assignment 0, pretty much what it does is if I gotta activate. Wait, my keyboard is going a little slow. Give me a sec. Better source. If I activate my virtual environment and I go into the assignment, right? I have this operations file. And pretty much what he has us doing is do chroma keying and flipping an image. So it's our first assignment for our class. And what it looks like is if I go into Yazzie, the fuck? Give me a sec. If I go into Yazzie, right? We can see the structure of this assignment. We have a chroma keyed and a compass image. So this is the default image. This is what happens after chroma is activated. And pretty much what chroma does it takes this background and this falcon, right? And then for any pixel that is around this green hue, right? Because the green is pixelated, so there's different hues of green. For everyone that looks like that, or within a threshold of this certain pixel color, we'll replace it with the background image. And so in the end, you'll end up with something like this. And then with the flipping, you take this compass image and you flip it horizontally and vertically. And so that's what I worked on. It wasn't too difficult. And yeah, it's just getting used to the new libraries because I haven't used what's it called? I haven't used NumPy in a little bit, and CV2 is completely new to me. So getting used to that has been a little weird. Not weird, but it took a little bit of time. But outside of that, it was pretty simple. You just parse through the array and replace some things here and there, right? Um, yeah. And so if I run it, I already ran it. So in the output, it will show what it looks like when it's flipped, right? And then my chroma keyed image, right? I think the only issue I had was I didn't read the instructions clearly enough. And so um, sorry, I should do this. Yeah. Up. When I was doing the chroma keying, you have to calculate it within a threshold, right? Which is done here to compare it to the threshold, right? What I did was I didn't use Euclidean distance. Instead, I just used a simple base case, and that didn't do a proper job at chroma keying. And the output was something that looked like this. Like it still worked, but there were still holes in the image here. So I had to fix that today. But yeah, pretty cool. Pretty cool. Yeah. So let's get started on reviewing some neat code. What am I doing? Let's see. Well, I need Obsidian. So we can do tmux here. And that'll be the notes, and we can disconnect. And then we can go into our dev neat code. All right, let me choose an easy one because I'm kind of tired today. Tmux here and tmux rename session neat code. All right, cool. Yeah. So let's open up Firefox neat code roadmap. All right, let's see if I can find an easy one for myself. I guess the easy one is one I did recently. So number of islands. And here is the question. So given a 2D grid where 1 represents land and 0 represents water, count and return the number of islands. Let me also do this. I want to get into the habit. Oops. Umpire solving method. Okay, umpire interview thingy. So understand what the interviewer is asking. So given a 2D grid where 1 is land and 0 is water, return number island is formatted by connecting adjacent horizontally and vertically and is surrounded by water. And so we can assume that there is a layer of zeros around here. So that, yeah, I guess. All the edges are water. And we just want to count how many islands there are. So here there is 1 consecutive island. And here there are 4. So there's 1 here, that's a 2 by 2. There's a 1 by 1 here, there's a 1 by 1 here, and there's a 2 by 1 here, giving us 4 islands, right? And so this looks, so what does this look like? It's a 2D grid, so it looks like, I want to say the obvious answer, and it looks like a backtracking. It looks like a graph question, right? Because it looks like a graph, but also looks like a depth first search question, because in a graph, to search through different connected nodes, you would use a recursive searching algorithm. It doesn't have to be recursive. You can implement them iteratively, but yeah. Yeah, I gotta really work on that match thing. I can't, like, I know what it is because I've done it, but I don't know how I derived, like how I got to that point, you know what I'm saying? Plan a solution with appropriate visualizations and pseudocode. Let's do that. I'll get my mouse. So if we get to Excalidraw, let's get rid of some of this. How do I zoom in and out? I can do it. If we go into Excalidraw and we go ahead and start drawing, we know that we have some type of grid. This is kind of tiny. And then in the grid, there are islands, right? This is not a good picture. I don't know why I changed my color. The color doesn't mean anything at this point, right? And so let's say here's an island, 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 here's an island. So this is 3 islands, really. And so what we want to do is we want to search through the array. I should probably choose a better color. To go through the array until we hit an island. And once we hit this island, we can search around it. So we can search here, 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 and here. If nothing returns there, then we just know that we have only reached 1 island, so we have 1. And then we can continue searching through until we hit another island here. And then once this is done, we can search from here, here has nothing, and it's already been visited, so that might save us some optimizations that might optimize our solution a little bit if we don't allow ourselves to visit a node that has already been visited. Let's see if that would break it though. Let's say, I don't know if it would, because if it was already visited, it will be either counted as an island or water. So I guess that could be a good optimization. So let's say that's implemented. We don't gotta include these 2, right? But then this one is nothing either, and it hits this island piece here, and then the same thing happens again until it hits this island piece, given that it looks around as well, and this hits this. And by the time that's done, we increment this value by 1, giving us 2, right? And then back to searching we go here, right? One important thing is, like, this is a land piece, right? But it's already been visited by this island, so we don't want to search again. So we need some way to count the visit. So we can do a visited set, tracking the coordinates that we have visited. This would also save us some time with optimizing the algorithm. So this will probably be the better solution. Or what I did, well, what I remember I did is once I visit land tiles, I would convert them to water tiles. So this would be water tiles anyways, so that when we iterate through the array, we ignore it completely, right? So we ignore it completely till we reach one that isn't a water tile, like right there. And then we can go ahead and do the tracking again, giving us a total of 3, and then until we reach the end, right? So I guess this was helpful because I remember when I solved it, I did it through um, changing the matrix itself. And one, we don't know that the matrix is changed. And two, if we are visiting, it saves us time if we don't allow ourselves to visit nodes that have already been visited. So instead of going here, we just skip it completely and start from here, I think. And yeah, so at the end of it is 3. I'm guessing the time complexity will be at the very least n by n, right? So that's n squared. And then the depth first search algorithm will probably be 4n, since we have to search for top, down, left, right. It might be a little bit smaller than that given the optimization, but this is probably the time complexity. And I think it just simplifies down to O of n squared, right? So yeah, let's go into the implementation. Well, what's umpire thinking? So that was the plan. We got to implement the code. Implementing the code. Is there a clear button? Yeah. So let's put our plan into pseudocode. We need some depth first search, right? Where we are going through, if it's water, keep going. If it's out of bounds, keep going. And then we gotta do, if it's land, we do the recursive tracking of top, down, left, right. And that would be all done through depth first search. And then we also want to do our looping through matrix. So giving us the, whatever gives us the n of the power 2. And as we loop through it, it would be like for I in range, let's do x. No, for y in range of len grid. Right? And then here it would be for x in range of grid at the first row. And then that would give us a grid value. So val equals, this is kind of useless, but I'm gonna add it anyways. Y of x. So you don't need to do that part. It's probably just taking up space. And then we want to check if val equals 1. So that means we found our, and 1 is a character. So you gotta make it look like that, right? So if it's 1, then we can go ahead and look into it, feeding in our y and x value. So depth first search will keep a y and x. And then we need a global incrementer. So total num, which is going to start at 0. And then after doing that, total num equals 0. If it's land, we also need to either track using a set or changing the matrix if allowed, right? So that's the basic thing, I believe. And so, yeah. So if you want to do a set, I believe a set is initialized by doing visited, which is our name, and then set, and then In that under that comment, you can go ahead and do visited dot add, and then some value there. Um, all right, bet. So we can do if water, if out of bounds. So if let's do if out of bounds first, because if we do if water is first, it'll give us a segmentation error. So if out of bounds, so if y is less than 0, or x is less than 0, or y is greater than or equal to len of grid, or x is greater than or equal to len of grid of 0, or we do, where's that button? Oops. I think that's how you do make it look pretty. Maybe not. Or grid of y x equals 0. Give it, meaning that it's water, right? So if any of that is true, then we can go ahead and say to return, right? If it's land, so if grid y x is equal to 1, we can then say, so if it's land, we can, since we're not doing a visited for this example, we're gonna modify our matrix. So grid y of x equals 0. So we're changing it to water. All right, bet. And then we gotta do the recursive tracking, which is DFS. Y minus 1, 0, y plus 1 is not 0, it's x. So that goes left, and this goes right. And then nothing really needs to come out of this recursive call. Yeah, nothing really needs to come out of that recursive call, because this is really just done so that we can alter the grid if we need to. Yeah. What does this say? What does this mean? Did I fuck up? Whatever. Total num plus equal 1. And then we can return total like that. And that's how you do it. Getting kind of tired. It's been a long day. I think I'm gonna call it there. And yeah, at least we got something going. OBS.